Would you like me to email them to you, Joel?
No, I'll pull them off the website where I believe Jim put them up.
Okay. Or I can give you the link here if you'd like.
Wrong machine is on Jabber.
I just put it in the chat here.
Yep.
I just turned my mic down a bit. Is that better now?
That's actually a little too soft.
Okay, well. How about that?
That's good.
I'll leave it there then.
Okay, I've got your slides and I'll present them when we're ready.
Can just to check if you got the last version, can you go to the last page?
Okay, just a second. It's your second half of future focus areas.
That's it. Good. Okay, he's got the latest version. Thank you.
Okay. And with that, thank you all. This is the Service Function Chaining Working Group at IETF 97. Thank you all for coming. I see quite a lot of people, and I really appreciate that. We have 2-minute takers, Ignas Bogdas and Gaurav Agarwal. So my thanks to both of them, because we really need that. And we're going to try to arrange ways to get that covered more consistently in the future. But I really appreciate the two of them stepping forward to do that. If somebody will copy things to Jabber, we could use a Jabber scribe. I'd forgotten to arrange that in advance. So if thank you. Tal has just agreed to take care of that as well. So we're covered there. Note well, this is important. People, I know it's just procedural, but it really matters. Please make sure you understand what you're granting us with the note well, in terms of copyright, in terms of your commitment to IPR disclosure, so that we don't have a problem down the road. Mostly now everything works, but it is important. So I'll leave it up here just one moment. I've been putting it up before we started so that people could see it. This is the agenda. Obviously, that's a very tight agenda. I'm sorry, but it is what it is. We had lots of requests for time, and even so, not everybody who asked for time got it. We prioritized things which were of urgent concern to the working group, and there are even things where if the working group starts discussing, I may extend the time slot. But I will have to cut off time on a regular basis. So I hope folks will understand if I cut off the mic line, but I want discussion. The point of this is face-to-face discussion. Having people simply present is not the purpose of the time here. So I'll give people just a moment to look at the agenda and let me know. Come to the mic if you see that there's a problem or a need to change it. Some folks found our representation a little confusing. The first time is the time from start of meeting. The time in parentheses is the local time at which we expect to transition each one of these.
Okay, Leon, on the agenda, this one, we want to kind of switch two of the spots that Eric owns.
We
had done
right.
That for the request,
you had asked that we switch your two
yeah,
presentations.
We're going to just go do that ourselves. So.
We can happily switch them, no problem at all. I'm sorry, I told you we would do that and we forgot. Perfectly reasonable, thank you. Status. So we're going to be discussing a couple of the documents that have been adopted, but not all of them. We are going to spend time today discussing the control requirements, and I believe David's going to present that for us, and we appreciate that because the pen holding author couldn't make it to this meeting. This happens. there are some ongoing discussions with the area director who has some concerns about our direction with this, but I want the working group's input on it so that I'm representing the working group's view when I have those discussions. Because in general, my personal opinion, while I certainly, as all of you know, have plenty of them, is not what determines things. What matters is what the working group wants. So my focus today particularly is going to be on hearing you folks. We are progressing the NSH draft. As people know, there's lots of discussion on the list. We don't have that scheduled for presentation this time. We do have a presentation on the best BGP control proposal, which has prompted some of the discussion. The actual details of how BGP is used belong in the best working group. That's not ours. But making sure it's using service chaining the way we've defined it is our remit. And so we want to collaborate to make sure that we get good answers. So Adrian has agreed, and my thanks, because he's double scheduled, to come present that work here a little later. I do want to note in that context, it is okay to bring up new issues. It is even okay to say, hey, I know we discussed issue foo, but I just discovered there's a problem with what we did. Based on this new input, we've got a problem. If that's true, we are obliged to discuss it and resolve it. We don't get to ignore it because we already did last call. On the other hand, if we had the discussion and the working group chairs called rough consensus and we completed last call and you don't have any new input, please do not simply re-raise the issue, because we will have to say, wait a minute, there's nothing new here. And I don't want to do that to people. But there are some substantive discussions going on, and we want those to take place. I am not saying we can't have those. We must have those discussions. I just want to remind people of the distinction, because if there are new technical things, we got to address them. We can't just ignore them just because it's late in the process. And the third draft that's on the working group plate is the hierarchical draft. And the authors have said, hey, we done with this? So at our request, they have sent a note to the working group list saying, hey, can we have some reviewers? Can people look at this? Because my concern as chair with the draft is, can I tell the difference between silence is consent and silence is nobody cares? They are two different things. One gets a document advanced, one doesn't, but it's sometimes hard for us to tell. There has been one person who has agreed to review the document. I'd love to see some more reviewers. I'd love to see some comments on the list, comments saying, if you like it, if you think it solves your problem, let us know, because we as chairs need to know, is this important work? I think it's interesting work, but as I said, that's not what decides things. We are working on other documents, as was mentioned in the results from the interim meeting and discussed on the list. We have to figure out what we're doing with the various metadata documents. There are a couple of documents on allocations for type 1. We have to determine which of them does the working group want to advance and how. We could say none. You can tell us all. You can say standards track. You can say informational. While I think there are some reasons for making the choices, we need to make that choice and move that work forward. One of the things we're a bit concerned about as chairs and working with the AD is that a lot of the work has not been moving as fast as we'd like to see. So this is a topic we want to see. Also the MD2 work, and we're going to have a presentation a little later from Betchit on the Sarakaya type 1 and type 2 draft. We have to figure out what documentation do we need for the type 2, where do we want to capture it, what is the meaning we need to have in our documents, what is the important information for us to capture. We also need to progress the OAM work. My apologies for not having moved that forward before I stepped in as chair. So one thing I will mention, we are going to be looking for a new co-author to work with Carlos on this. So if you're interested in the OAM work and you would like to work actively on the framework document, talk to us, send a note to the list, but thank you, Greg, I see your hand. Minute takers, please note that Greg Mirsky has already volunteered, so that may be the person, but we want to know, we certainly want to involve anybody who's interested. We're going to have a new co-author, because I am not, as chair, going to co-author that draft. It causes me, I've got enough trouble trying to keep my hat straight. I don't want to confuse everybody all the time. It's important that I have a very clear role. And it's from all my discussions with a lot of different members of the working group, folks agree that getting the OAM work moved forward is important. We are likely to have an interim meeting, probably to discuss metadata and OAM. I hope that the NSH work will have been finished before then, so that the NSH work will not be the topic. We're currently aiming for January. The location is not set. There has been a suggestion that Boston is the best compromise among locations, or maybe the East Coast, but we don't have a host. We are still working on arrangements, and if there's a good reason to hold it somewhere else, we can do that too. We want a lot of people to be able to show up. The purpose will be discussion. There will be some presentations to set the tone for discussion, but the goal of having an interim meeting for a couple of days is to really have discussion of the issues and get people engaged in working forward on topics. And in order to make it easier for folks to decide, is this something important, Jim and I will make sure we get a rough agenda, not necessarily the final one out, a lot more than 2 weeks before whatever date we set for the meeting. So yeah, the final may be 2 weeks before the meeting, but we will get a rough agenda out so people know, why are we doing this? Why are we asking you to go to the trouble of coming? We will also try to have provision for remote attendance, but in terms it's harder than face-to-face meetings. I think everybody knows that. So with that, just let me pull up. Now let me find. No, that's not right. Oh, I don't know how this tool works. We'll just do it this way. It's good enough. Brady, you're up.
Okay, hello. Are you going to present the slides?
They are on the screen. You are on the
Okay,
Open Daylight cover slide.
Okay, I don't see anything on the on this Meet Echo tool. I'm not sure what slide you're on.
You tell me what slide you want. I'm on slide 1 right now.
Okay, all right. Well, let me present myself. Shall I be showing the video as well?
If you can, it would be good. Helps people to see a face.
Okay, how's that?
That's at least that's got your face. That's good.
Okay, I don't know if that's good or bad, but okay. So hello, my name is Brady Johnson. I work at Ericsson. I'm leading the Open Daylight SFC project. I'm also leading the OPNV SFC project. So I've been asked to present today to show how we are implementing this IETF SFC RFC. And I'm happy to do that. I'm very happy to have IETF SFC is a backing implementation for the work that we're doing. So, Joel, if you could go to slide 3, please.
There you are.
Okay, so I'm going to open it up here on my computer as well. So, okay, so what I'm showing here is how we're actually implementing the IETF SFC specification here, and I think it's very similar. I think there's only one point where it's not exactly the same as the specification. That would be the rendered service path, but we do have plans to get closer there. But as you can see, we have the service function chain, which is our abstract ordered list of service function types. We have the SFP, which is where we optionally specify concrete information about an SFC, and then the rendered service path, which is the actual service chain, which combines information basically from the SFC and the SFP. And then, of course, we have the classifier, which I like to describe it as the entity that maps the subscriber or tenant traffic to actual service chains. So I tried to kind of capture the way that we're implementing this in this diagram here, where the SFC are the types, The SFP actually includes information from the SFC where you get the concrete service functions and the concrete service function forwarders. And then you can see this red line is the actual rendered service path. At the bottom of this diagram here, I have a link where you can actually look at the well, let's call it the source code. It's in Open Daylight, we use Yang, which is a modeling tool. So you can see the actual models that we're using for this implementation. Okay, if you can go to the next slide, please. Okay, so
On slide 4.
good. Okay, so here I'm showing a use case that we have implemented. It's a typical use case you can implement with SFC. This one's interesting. I think it includes pretty much everything you can do, but we're highlighting here the service function reclassification and branching. So you can see here you have 3 different service functions. You have a DPI, which is detecting traffic, and when it can, it will reclassify. We have a quality of service service function, which can do rate limiting, and then an HTTP header enrichment service function, which will add HTTP headers and such. So you can see we have 3 different service chains: the green, the blue, and the red. So by default, all traffic would map to the green service chain and go through the DPI. And then once the DPI can detect traffic and determine if it's, for instance, BitTorrent or peer-to-peer, or if it's HTTP, then it would map the traffic accordingly. I used to work in DPI, and we used to always say the best way to make DPI faster is to not do DPI. So this is a really good way to do that. So, but I just wanted to show that, I mean, this is a use case that we have implemented. Well, not exactly, but we're able to implement something very similar to this, and it is according to the specifications where they talk about the reclassification and the branching. So, Joel, if you could go to the next slide, please.
We're on slide 5.
Okay, now I can see on the actual tool, so good. Yeah, so this is a rather complicated diagram here, but I'm explaining how we're implementing NSH. So the service chaining encapsulation that we're using is NSH, network service headers. And it's, again, this is kind of showing everything you can do with NSH and all the entities involved. So we would have 2 different chains here, the blue chain and the red chain. You can see the NSP is 1 and 7 respectively, and then you can see how we're decrementing the NSI here, the 255 to 254, 253, etc., as it passes through the service function. So the 2 service functions on the left, the HTTP and the NAT, are NSH aware, and then on the right here we have an NSH unaware service function, which is using the NSH proxy there. Okay, so yeah, on the next slide here now. So this NSH, we're using 2 different transports for NSH. We're using either VXLAN GPE or Ethernet plus NSH. This Ethernet plus NSH, we're actually implementing that now, and that will be available in Open Daylight, the Carbon release, but then also in the OPNFV SFC Danube release. So just showing the different transports we're supporting for NSH. And on that note, if you can go to the next slide, Joel. Yeah. So I mean, okay. So I originally started working in Open Daylight, and I like to point this out, that Open Daylight is just one piece of the puzzle, right? So Open Daylight SFC, I mean, it's really neat. It's cool. It does what it does, but you need more elements involved to get the end-to-end service chaining, and that's what OPNFV is all about, the Open Platform Network Function Virtualization. So that's where we actually integrate Open Daylight SFC into the cloud with OpenStack, with your real NFVs, etc. So if you can go to the next slide. actually we have a diagram here of how we do this, of what it looks like. So we have, as you can see here, an OpenStack environment, a compute node, and a control node. You have Open Daylight and OpenStack. We were on both, but Open Daylight on the control node. We're using Tacker as a VNF manager, which will actually Tacker is capable of reading the SFC configuration and spin up VMs for the service functions as needed. So it's managing the VM lifecycle for the service functions. And then on the compute node here, you can see that we have the service function forwarder in an OVS bridge. So this is OpenStack, so it's in the BRINT bridge. And we also have the classifiers on the OVS bridge. So the first release that we've done, we actually have this working in OPNFV. The first release we were using the Open Daylight NetVert project as a classifier. So NetVert provides networking for all the VMs. So it has all the context about the VMs. So very easily you can just add classification there for the VMs. And then that classifier, then they've added code there that will encapsulate NSH and send the packets to the service function forwarder. So this is the background I wanted to show that we are indeed implementing the IETF SFC. We've made really good progress. Let's see, we're working on Carbon now. The first release where we were able to pass packets through a service chain was Lithium, which was about a year ago. And then after Lithium, we was the Beryllium release, where we started working on integrating this into OPNFV. And the first release of OPNFV, we didn't really get much working, but the second release, the Colorado release, which we just finished, we actually had really good progress. So this Open Daylight SFC which is implementing IETF SFC, is working, and we have end-to-end service chaining in a cloud environment such as OPNFV. So if there's no questions on the implementation so far, then I'd like to get into some sort of improvements and things that we'd like to see in the specifications. Is now a good time for questions, Joel, or should we wait till the very end?
Well, if people have questions, they should come to the mic. Yes.
Hi, Tal Mizrahi from Morville. I just wanted to ask how the NSH is configured. Is that using Netcon for something else?
Yeah, so in the service function forwarders, they reside in an OVS bridge. So that is all configured using OpenFlow.
OpenFlow. Which version?
1.4.
Okay, thanks.
Yeah.
Hi, this is Kent Leon. So actually, can you go back to the last slide on your implementation? So actually, I was a little puzzled by this drawing because I guess to clarify the point that the last SF for the SFF to deal with in this case is SF2, right? But it seems like what you show here is that your SFF, I guess, extends your NSH all the way to the egress classifier, and then the egress classifier is the one that decapsulates everything and then sends it out to that. So that seems to be different from the SFC architecture. Is that correct?
You're right. Yeah, you're absolutely right. And that's the first point on my next slide that I'd like to cover. Yeah.
Okay, that's good. Yeah.
I didn't hear that last part.
He agreed. Go on.
Okay. Yes. Yeah. So that's the first point here. I mean, terminating SFPs and handling SFP egress. So as he pointed out, it should be the last service function forwarder on the last hop of the chain who should remove the encapsulation. But then later the spec goes on to say that it could be done by any SFC boundary node. So there's a bit of ambiguity there. And here I mentioned SFC egress boundary node. So Yeah, in one part of the spec, it says that it should be the last SFF. And another part, it says it could be any SFC egress, I'm sorry, any SFC boundary node. There's a bit of ambiguity there. And in our case, for instance, in OP and a V, we really need it this way. Because if we can go back, Joel, to the previous slide, it's really difficult to show the pipeline here, but if we take a look at the pipeline here, if the service function forwarder on the last hop removes the NSH encapsulation and then sends it back through the pipeline, that packet will get classified again. So thus causing a loop. So, and the reason that will happen is all of these, as you see here, the ingress classifier, the SFF, and the egress classifier, it's all hosted on the same OVS bridge. So we have something in what you would call an open flow. We have this application coexistence where we're having to share multiple applications on the same bridge. So if the service function forwarder, like I said, removes the encapsulation and sends it back into the pipeline from the beginning, that packet will get classified again as if it had just come in. So there's a loop there. So we need to send the packet to what we call the egress classifier with the NSH header on, which the egress classifier looks at that NSH header and makes sure it's the NSI is the index is the last hop, and then it will remove the NSH encapsulation and is capable of sending the packet where it needs to go. So, Joel, if you could go back, I'm sorry to bounce you back and forth. If you could go to slide 9, please.
That's not a problem, but we should be aiming to wrap this up. We're a little behind schedule.
Yeah, all right. So that's that point there. So yeah, we need a bit more clarity on that. And I mean, that's a bit of the background of why we need to be able to do it from any SFC boundary node. We can take this offline via email if you'd like. I'm always available on the Open Daylight SFC email list and also on the OP and a V SFC list, and through, I guess, through Joel and the SFC chairs. So if we can go to the next slide, this is the last slide. Yeah, there's another set of use cases related to service functions that act as proxies, which aren't really handled, or it's not really mentioned in the spec. So, for instance, like a TCP proxy, that is a really interesting use case. So a TCP proxy, which would be like any sort of service function that needs to modify the packets, which would be like an HTTP header enrichment, any sort of internet cache or anything like that, needs to modify the packets. Then the TCP proxy would terminate the TCP connection with the client and establish a new connection with the server. So you can imagine that when it terminates the connection with the client, it has to send back the TCP ACK and all that and establish a new connection. So these are packets that are being generated by the service function. So it'd be interesting to see your approach on that from the the IETF approach on how to handle that. And then there's some similar interesting use cases with the transparent cache. How would that work with reclassification and such? So yeah, these are the focus areas we'd like for you guys to look into. Are there any questions on that?
Somebody coming to the mic, thank you.
Okay.
Yeah, Brady, this is Kent Leon again. So yes, on the TCP proxy, there is a draft by Pinot, packet generation draft, and there are different options. So there are proposals in what the solution is, and probably would be worthwhile for discussion among us to figure out which one works the best, basically. So it's being addressed in one of the drafts.
Good. Okay. Thank you.
Packet generation by Pinot. Oh, okay. Needs to be refreshed.
Stuart, Brian. So if you go back to the previous one, I'm trying to work out whether we're discussing an artifact of the SFC fundamental architecture or an artifact of the particular way you've chosen to implement it, which allows this reentrancy.
The reentrancy itself, I believe, is a consequence of their implementation, but there have been a number of discussions about egress classification and egress behavior, and it would probably be good to get an email to the list saying, in general, in the SFC context, if you're assuming NSH and everything else, what is the issue? So Brady, if you can send an email to the list to spell out in the context of the standards as distinct from the implementation, what issue you see needs to be addressed, it would be very helpful.
Okay, yeah, I can do that.
It seems
And when you say the
fundamentally
list,
to me that when you've decided to egress the packet, you better egress it. I mean, it shouldn't be any doubt. Otherwise, it's just random packets wandering around the network, which is probably not what you want.
Yes.
yeah.
Okay, any other questions, comments? So, okay, thank you, Brady.
Okay,
I'm now
very
going
happy to be
try
here.
to present this from there. Betchett? There's a microphone there. Please stand in the pink box. Right there. I believe we have the latest version.
Yes, that is the latest version. Okay. Good morning, folks. My name is Bechat Sarikaya. So I'm going to talk about today metadata type 1, type 2, service function chaining, metadata type 1 and type 2. Okay, next slide. So basically we have this NSH draft from Paul. I don't know if he's around. Which defines the protocol, so-called data plane protocol for SFC, and also the syntax for metadata type 1 and metadata type 2, as I have them here. Now, so basically there's base header with lots of flags, and then service path header, and then the context data. So currently we have this mandatory context headers, 4 bytes and 4 of them each. Now there's a new format that has been proposed to combine all of them into a single 16 octet context header. So we have that. Then metadata type 2 with similar base header, service path header, and then the rest is basically more flexible in terms of TLVs, type length metadata, although type length, and there's other things like metadata class fields and so on. Now, some issues have been raised, including from one of my co-authors here. For example, metadata class is why so many bits for that field, and then why cannot we have bigger size for type field. Okay, next. Now, the problem I think Joel mentioned also is we have the SFC is very popular, so many use cases. We have already some working group drafts about the use cases, and we have also several other use cases mentioned in several drafts. So SFC has application in so many areas, fields, and so on, mobility, data center, OEM, and so on. So then more, I should say, quote unquote, modern use cases like extreme low latency services, ultra high reliability applications that 3GPP is defining these days. So we have these so many use cases, and also we have many drafts that are defining data, SFC data, metadata, type 1 and type 2 for these use cases. Now, we have some drafts defining only the format or syntax of the metadata. Some drafts are defining also semantics that go with the metadata. Okay, so what to do with what do these fields mean, identifiers, everything defined, mean, and then how an implementer can implement giving these syntactical structures defined. So what we call post-processing instructions. Now, how to so the issue we try to address in the draft is what type of approaches the working group can take in order to standardize the metadata needed. And as Joel mentioned, we had an interim, and this was discussed a little bit. Actually, this draft is doing basically the work of the chair. So try to help the chair in this process, give some help, extend some helping hand in this process so that maybe we can make better progress. Okay, so how to standardize metadata needed by a diverse set of SFC applications while ensuring backward compatibility. You might say, what is this backward compatibility? I already mentioned the changes in the syntax in the previous slide. So we may have some people already implemented with that syntax, which is already in some of the drafts, so NSH draft, and then we have new ones. So that may cause some backward compatibility issues. Okay, next. Okay, so next I continue with individual drafts, what we have in hand right now. Started with the Jim Shar's draft about metadata type 1, what have been defined so far. So this draft Gishar defined DCL data center type 1 allocation proposal. So the use case is data center use case, which is a really working group draft. And so that this draft defines, it has been revised many times, defines source node, source interface, and tenant ID. Then destination, source, and opaque service classes are defined. Now, the NSH draft allows many bits for the designer to play with. So this D bit and F bits have been defined. So D bit for destination class and F bit is opaque service class. We can have service stack type of opaque service and to identify particular flow, transaction, and application message. And then we can have an application ID for opaque service class field. Next, another type 1 metadata defining draft is this draft Napper. This is a mobility SFC mobility use cases draft. The needs of type 1 data metadata needs of the mobility use cases. So the identifier defined contacts, sub endpoint, and IDs, and then the service information fields. It has sub fields to control sub endpoint ID types. Now, so we have these IMC, MSISDN, M10 flows, home identifier, and so on. So a set of bits have been defined, bit structures or flags. Now, tag bits for service information types. So we have the service information. What's service information? Okay, so we have these tag bits, and and define more of different types of service information. Okay, now here you can see the an example from their draft. The CAN field is connectivity access IP CAN. Those of you familiar with 3GPP, it's used to identify which network you're connecting to. Could be 3GPP, GPRS, or DOCSIS, cable network, or DSL network, and so on. It's fixed network. So although we're talking about mobility use cases, but you know you may be connecting to a fixed network because of your Wi-Fi, for example, the mobile so-called UE. And then we have the app ID describing flow type, and then CON field access congestion level. Now they also defined type 2 TLV, which is basically empty, and they're proposing to give it to 3GPP and to use for them to use whatever, basically for the needs of 3GPP, whatever metadata type 2 they need, we can define with this one. Okay, next I think is the draft bank. Here, this is also a type 1 metadata type 1 approach. That I just noticed that they published a revision which I didn't cover here. It seems to be a lot of changes.
Dan Bogdanovic, Volta. I have a question with essentially some proposing some kind of a path selection based on source destination and few other descriptions. How is your draft different from some other drafts that are proposing similar solutions, and what would be the benefits of your over the others?
That's a very good question, actually. But my draft is not about that, by the way. My draft is basically classification draft. So what do we have at hand? So and here, same like the question you asked. So there are drafts talking about the same thing, but they're defining different types of identifiers. Yeah. So what to do with those? That's a very good question, I think. So we should discuss. The purpose of my draft is not to discuss those issues. So it's just basically give what we have at hand right now, and then discuss what the working group can do. We'll see some slides at the end. How the working groups can proceed in standardizing these various type 1 and type 2 metadata defined in various drafts. What type of approaches we can take. So we didn't address the issue that you're saying, oh, do we need these fields, or some draft is talking about this type of metadata, probably for the same use case, but they're defining different type of metadata. So what should we do for that? That is not the purpose of this draft. But it should be discussed. I agree. Okay, so the draft bank is security use cases. So they defined the use cases draft themselves from same team, I think, and the identifier defined the session ID and tenant ID, and then destination source classes. There's a D bit for destination class. They defined more bits, but those are not covered in this version. But I'm gonna maybe make a revision to cover the changes ongoing. So security context allocation may also be defined. So one aspect of this draft is, although we define them as type 1, but they can also be defined as type 2. And we have another draft, draft 9, and NSH broadband allocation defines, again, type 1 metadata for broadband network use cases. So source node, source interface, user, and VLAN IDs are defined in this draft. Okay, next. Type 2 We have draft Sarikaya, which is from our same authors as this draft, my draft. Here, the use cases are just, so it seems like this is the only type 2 defining draft, although we have another one we'll see next, but that's as a different nature. The use cases addressed here are parental control, traffic offload, extreme low latency, high reliability applications, and identifiers. Basically, 4 identifiers are defined, very clear: host ID, subscriber ID, slice, and service ID. Now, and then the bits to control subscriber ID and service ID allocations. And so the distinct characteristic of this draft is use cases are also defined in the same draft, and then a lot of normative behavior with the data defined, and then the privacy considerations, for example. So for some data, privacy is important, so what to do with those. IETF requires such things to be defined. Okay, next, we have this Paul's draft Quinn about NSH TLVs, defines a lot of maybe 12 or more type 2 metadata. So the purpose of this draft is to document syntactic structure of the TLVs. It's a registry type of draft, basically. Of course, it has merits just because or based on that. Now, this draft does not document the normative behavior that comes with these TLVs, how to process them. But this is key for interoperability. If you don't have those, then how the different implementations interoperate. Next. Okay, so we have OEM draft PENO, which this is a very different scenario, reverse packet request. And this is very involved draft. A lot of things are there. I didn't really cover all the details here. We have the draft PENO SFC app ID draft and defines classification engine ID, selector ID, and so on for app ID, which is also in the registry draft. Okay, next. I guess that's all. These are all the drafts that I was aware of, given up to today. If there are new drafts that come up, we'll be happy to include into our draft some description of each of those. Okay, now the big question: how should the working group proceed? No, previous slide. Okay. Now here we suggest. Oh, you see?
Go ahead, finish this page. Go ahead, finish your.
This one?
Yeah.
Okay. Good. Okay, you're going quick. Oh, let me finish. Okay. So basically, we can have registry approach option. One option in standardizing these TLV or the metadata type 1, type 2. It means include all the data defined in one draft, and maybe separate type 1s and type 2s in 2 separate drafts. So far, we have only for type 2, but we don't have any type 1 register draft. Now, or we can let everybody define those and then consider them case by case. And if they are found useful, then standardize them separately. So I call them case by case approach option. Now, we can have hybrid cases. We can have registry and case by case with semantic information, or we can have case by case plus registry of only type 1 or registry of only type 2. Now, informational. Okay, quick. Now, the other big issue that was discussed in the interim is how do we, when we standardize, what type of, is it informational or standard track? So here, registries, I think, could be informational, although type 1 registry, questionable, can we make them informational? And case by case, probably they should be standard track because they define the normative behavior.
Yeah.
Okay, that's it, actually.
Yeah, I think your next page is asking the comment.
Yes.
Thank you too. I think that the way NSH defined metadata giving a lot of potential capabilities. Then of course introduce some complexity. But recently we discussed to add additional the text for the NSH to strengthen about the implementation, which solving those interworking the concern and also backward compatibility. And for the Type 1, we're clearly saying that we're not going to, context data, we're not going to specify the data semantics, only have the data, so required control plane to giving pass this data semantics to the service function. That's the requirement, both for the service function implementation as well as control plane. For the metadata type 2, we are saying, we need to put a certain rule how we process those the TLVs. That will help this backward compatibility. I think
question for you and for both of you. There is a distinction between specifying how they are processed and specifying the semantics. So to give a clear meaning, for example, there may be a subscriber ID, which is an encrypted, it's just an index. And the semantics is, this is an index for use in identifying the subscriber. The processing may be use radius, use diameter, use SAPC, use this, that, the other thing. We should be clear about which aspect we need to standardize versus which we don't. I think the semantics need to be clearly spelled out.
That's a
Am
good
I
point.
understanding you correctly?
Yes, I agree. Yeah, it's a good point. Yeah.
And that was Lucy Young for the Minute Takers. Please, everybody, do give your name when you come up to the microphone.
Yeah,
Okay.
I'm Lucy Young from Huawei. Yeah.
Yes, I also agree with Lucy's point. Actually, please write your comments on the list so that we can improve the draft. So.
Praveen Moore, Nokia. So I'm the co-author of the broadband draft, and what the approach there was that you will have different types of use cases, and you pretty much can define your metadata at a general level, and how you want to process is just a reference. It is not a standard thing, and so you can define your metadata 1, and you also refer to the case of, like, there is also a reference to 3GPP. So the way, so when we talk to even the broadband folks, what we found is that they don't need any extra metadata, but just the subscriber ID and the 2 metadata context headers are good enough for them. There's not much information they need. Whereas in 3GPP, there are many use cases where they would love to have some more information. And the approach here is more like how you have done with diameter, that you give a TLV to 3GPP and let 3GPP be the body which comes up with the use cases, what they want to define further. So that's the approach really. And I think that will be much simpler as compared to if we start defining ourselves here, what are the use cases of each particular standard body out here. Thanks.
Well, I think that the processing instructions or how to process the data is not that should not be lightly taken. So that's the point I don't agree. But the other points you made, I agree.
I don't know.
Because then how do you interoperate, right? So you define these,
and that is
then
why we will define
some guy he understands one way and implements it that way. The other guy understands another way. If you don't clearly define.
That's exactly the definition in the broadband draft, right? That this is the definition what you can use, and that's the reference, and you can program that in your SFs or your wherever your steering function is, and after the classifier, and you can put that information. So that's what is getting defined. Right?
Okay, you call that okay.
Yeah, Kent Leung, I agree with that actually. So going back to your comments asking for type 1 and type 2 kind of standardization, right? I think Paul Quinn's TLV for type 2, I think that's sufficient because you're defining basically the other TLV, the values, and also the semantics of it. So I think that by itself, even for the, I guess, the new 3GPP attributes or whatever you want to call it, a metadata, you can add to that, right? Because that's just it is a registry, exactly what you said, right? It's a registry for type 2 TLVs, right? So I think that's the way to go. For type 1, I don't see why we're putting yet another registry when we're already defining them in the drafts in each one of those, right? Which ones gets adopted by the working group. Once it's adopted, right, it has a syntax, it has a semantics, such that it seems like that you would be already standardizing it. If you keep another registry, then now you have to keep them in sync, right? One that's for type 1 registry plus the one that became RFC. So I'm not sure why we need to have 2 type 1 kind of registries. I guess that's my comment.
Okay.
Dave Dolson, Sandvine. If there was only one format for type 1 and we, picked one and went with it, I think that'd be okay. But I don't think it serves us well to have more than one type of type 1. I understand that one could manage this.
I mean, per use case?
I understand that one can manage this as a control plane configuration. What does type 1 mean? What's the layout? But I just think, as we get, if we had dozens of these different ones, nothing would interoperate. So, and also there are networks that do 3G and fixed line. I don't think it's I think you're going to have equipment that wants to run in a common network, and I think you're going to have trouble with things talking to each other if there's a proliferation of what type 1 means.
Yeah, thank you. But my reaction is that, okay, like for example, data center, we have Jim's draft. That seems to be well understood and agreed, right? But the other, some type 1s are not like that. So then we should discuss those in depth and make a decision, yeah.
Lucy Yang from Huawei. I think if we want to do something, registry for the type 1, that only makes sense for the control plane to easier to inform the service function. Instead, you just say the data center for data center case. Instead of saying the bit 1 to the 5, describe the data structure. If you want the registry to easier to reference the different data structure, doing the registry per control plane, not for the NSH, not for the data plane. That's the first comment.
Well,
Second comment, I don't see that's any use case. It's up to the it's up to the implementation to determine whether they want to use the type 1 to convey the metadata or they use type 2. Both should be support. Any use case should be possible to choose either one.
Yeah. Well, for the type 1 registry, since we don't have an example, but what I meant is we can put all those in one draft, whatever all the type 1 drafts, and then that will be type 1 registry draft. You know what I mean?
Since there's so many types, I don't think putting into one draft makes any sense.
That's what I mean, yeah.
Last speaker, please.
But we don't have any
Leon,
example.
So I want to make sure that we're clear, right? I don't want to open the debate of the multiple type 1s or the control plane setting up. I think that's a separate debate, right? I think this is about what you're saying is that a registry for type 1 TLVs, right, or metadata, right? I mean, that's what you're
not TLV for
metadata.
Okay.
Sorry,
Type
metadata.
1, type 1 metadata. Yes.
Yes.
Okay.
So I think that's the debate, right? So I understand the issue with the multiple type 1 formats, right? I mean, that's already being debated. But my main question is that whatever, I mean, I agree, we're not going to end up with one, right? Because it's already been debated, right? Assuming there's multiple, right? The key is that they are already defined in whatever a working group decides to define, right? So that becomes the standard reference for your metadata for type 1, right? My question to you is that it sounds like you're trying to create a different registry of metadata for type 1. And to me, that kind of overlaps, right? So I don't quite understand the need for such a thing, right? So I want to make sure I'm clear with Dave and, so that I'm not debating the other topic at all, right? That should be left, right? But I'm actually debating your particular job.
Yeah.
Guys, we're now 10 minutes behind schedule.
Oh, sorry. Yeah, I agree. But it remains to be seen what is
Walter,
type 1
okay, Walter,
registry, yeah.
quickly, but give your name and...
Walter Vodafone, just a remark. When I remember correctly, some years ago, there were ideas to have the type 1 exactly for silicon implementation. And therefore, this should be, if it would be in silicon, then this should be defined very precisely and different to TLV. I do not know if anyone has still some plans to do it in silicon, yeah? But this was where the difference between type 1 and 2 came from.
Okay. Silicon implementation. Yeah, I guess everything becomes silicon after a while, yeah.
We need to move on. Dave? Thank you, Bechet. And try to move a little bit quickly because there's some hard time limits in
Okay.
here.
I'll try to be quickly. Hi, I'm David Olson. I'm presenting these slides at Med's request, so I'm trying to guide you through these. So this is about the control plane draft that we're trying to progress.
This is the control plane requirements draft,
Right.
distinct from
Control.
a control plane solution that we will hear about later from another working group.
So briefly try to address the scope of what's going on here. So referring to the charter of what we're going to do in the control plane draft, emphasizing that describing the requirements for conveying the information. So I think this is a theme here we're going to see is that this is a document about the requirements and it's not a protocol description. So please move. So what's not in this in draft is the protocol or an extension or any details on exactly what the protocol is or any criteria to select the solutions. So what it is focusing on is what kind of information is required to communicate to each component on each of the interfaces. And the editor's assertion that there's a lot of deployment considerations here and they're also out of scope in this document. Next slide, please. So this is the the way the authors viewed when they put the document together. And by the way, Joe, if you think I'm off track here, let me know. So clarify what are the implementation points, what are what is the architecture, so what are the architecture being about interfaces and components, so pretty high level, and also to provide some basic recommendations about how things should behave. Next slide, please. So the milestones of this document, April and May 2016, it's going to pass working group last call, and there were couple of versions to integrate those comments. Because in June it went to the IESG and received AD review in August. There's up to I think we're up to draft 7 now with comments from Ali, and I think there was a draft 8 as well. Was there one after this? Anyway, so where are we at right now? That's I guess the point of this. So these is a list of some of the changes that were made in response to Alia's review. Clarified, the document explains why there are no flow exchanges. More text about dynamics and about timeless control. I'm not sure what that means. Anyway, there's more introductions. I encourage you to look at the differences too. It'll help you explain what's up here. Introductory text to the architecture diagram. Some text to say that. Anyway, you probably don't want me to just read this. Anyway, there's a lot of edits, and we think Med also thinks that addressing the issues. So, question to Alia to whether she's happy with these, and next slide, please. I asked him, about why is there not a detailed model, and after looking back at his rationale, I accept his answer that this was a control plane. It was a requirements and architecture document. I'm not sure I agree with his statement that it's straightforward to get to the model from what's described here, but I guess I'm okay with his answer in general. Next slide, please. And Lucy had a comment that he wanted to address about more adding semantics for the mandatory field. And I guess he said he's added some text or thinks it's already covered. So I guess also to hear whether Lucy's okay with that. And I think that's it for the presentation of this. So if you have questions, we'll try to, I don't know if I can answer them, but we can capture them for the minutes and try.
And the questions he's raised about people having made comments, I'm going to be meeting with Aaliyah later just to go over the whole document. If you had raised earlier questions about the document and either are happy with the answer or are not happy with the resolution, please say so on the list. So let us know, because either way we need to know so we can go forward properly.
Aaliyah Atlas. So I also got a routing director review about the draft, which is part of what highlighted it. When reviewing the document, it's very easy to review what is in it instead of what is missing. And that is the problem. It also does not make choices. It obscures instead of clarifies. The information model doesn't need to be a data model, but it's not clear. I had several discussions with people who have tried to look at the control plane document and get requirements or some idea of what was necessary from it for doing control plane work, and it was not seen as helpful in that space. As part of my review, which those of you who are up to date on the mailing list, since it's several months ago now, saw, I pushed back that it doesn't make decisions and actually provide serious requirements. It says you could do this or that or the other thing, and not totally. If it's going to be requirements, we need to actually have the full discussion and push it. And obviously I'm going to talk to Joel in more detail, but I'm not willing to sponsor it the way it is. Thank you.
Okay, so I'll ask this since I'm here.
Sure.
So you don't think that, it highlights, interfaces C1, C2, C3, C4, for example, C2, I believe is the one that talks to the SFF. And so you don't believe that the descriptions of those is sufficient to, to give scope to a draft that describes the C2 interface or a scope.
There is a lot of commonality between what those interfaces are, and we are not going, I hope, to have a different protocol for each of those interfaces. I think it's much more useful to describe, here's the information, and this you need to do discovery, and then if you want to go through the functional architecture and say, this can be used for this, but it needs, in addition to this base information, it will also need this extra piece, that's a perfectly fine. But currently, instead of clarifying, I find, and I have gotten similar feedback, that it obfuscates the information and the similarities between the interfaces. Obviously, this is going to be a more detailed discussion, and I would very much like the working group to seriously look at it and think about what's missing and what types of changes what types of decisions that are given as choices could possibly be made. I would like to see it get worked on and be happy to get it into better shape. I am happy to request some more reviews so we have more opinions and perspective as well.
Comment. I think that in the control plane requirement, we define those the interface. That's just a reference point to specify the requirement. It's not necessarily required that each interface have a protocol, different protocol to implement. That's just for reference a point. It's not a recommended. Yeah.
It's very repetitive and confusing, but that's not the main problem.
So I think we've heard the issue. The chairs will be working with the AD to better understand the details of this issue and be bringing it back to the working group for resolution.
Hi. So I'm going to present the updated version of SFC environment security requirements. Next slide. So this is the overview of the architecture we consider. The thing I want to point out here is that we divided the environment between planes. So you have the SFC management plane, the SFC control plane, we just talked about, and the SFC data plane with the SFC tenants user data plane. What I would say is important to notice is that the tenants user data plane is not only providing the incoming packets, but most likely also the outgoing packets. Next slide. So the document provides an overview, well, a description of the 4 planes. So here they are: management plane, control plane. So control plane is also discussed extensively in another document, so we did not spend too much time on that one. The SFC data plane and the tenant users data plane. Next slide. So for each of these planes, we described the impact of each planes within the architecture, which means the interconnections between those 4 planes, and also the threat analysis performed from each planes. So control and management planes are, well, really the scope of the other document we just talked. So we do not extensively go into that, but basically, if you got a attack, well, if you got any control on the control plane, then you have a full view of all the traffic, and also you can fully configure this traffic and reroute everywhere. So you really have, how the name says, control plane, you have full control of the SFC platform. Considering the tenants user data plane, you can't really control that because that's the packets, the incoming packets from the users. So what you have to really consider is the interface between the data plane, SFC data plane, and the user planes. And but the thing, as I mentioned, the thing you have to also realize is that you have attack that can be performed from that plane, but also, I mean, from the packet, the input packets, but also from the outgoing packets. So some of the attacks that we consider is that, well, the user plane, the user is going to provide some input packets, and when going into the data plane, it's going to go through a classifier that's going to probably add some metadata according to some of the inputs provided by this user. Typically, it could be an IP address. So the IP, well, the user got some ways to control where the traffic is going to go to. So, for example, if some metadata associated to one IP address are associated to private metadata, or if you get control according to the IP address is using to direct that on a specific path, it can lead to some resource exhaustion attacks or some privacy leakage. The other thing is that because you got the input and output, you can also have a control channel, and by monitoring this channel, if you both on the input and the web server, you can also define how the architecture inside the data plane is handling the packets, so which are the different paths and so on. And at last, I'm just finishing for the user plane. If you got at the output end, depending, you can also craft some packets to define the location of the user or what kind of user it is. So suppose you have a website and you craft a specific packet, because it's going to take a specific path going through a mobile network or through a Wi-Fi network, then you can provoke some interactions with the user so that you actually know what type of network is using or where the location is really used. So this is the kind of things we would like to point out in this plane. Question?
Dejan Bogdanovic, you said at one point that the user on the user data plane cannot control the traffic.
No, what I say is that the entity deploying the SFC platform have little control on what can the user send to the platform. So the entity deploying the SFC platform has to consider is to provide some access control, and what we kind of require is that the access control is independent from how the SFC is handled. So that's we split these two functions, but I'm not sure I'm answering to your question.
One of the things is as a user, when I'm I have my, as you define it, user data plane. I want to be able, as a user, to control how my packet will transfer across your data plane. As a user, I want to have my own policy rules, how I'll go through that. You can give me some access to certain services according to my authorizations, but I believe that I should be able to have the full control over how the packet is being forwarded over your network within the authorization domain that you granted me or that I paid for it.
Okay, so as a user, so suppose you are you thinking as a tenant, as an ISP, or as an ISP? Yeah.
I think there are a lot of details in your question about which user and what level. Let's take that to the list because we're running out of time and it's a good question.
Yeah, let's talk after the meeting then. Then we had the user, then the data plane. Well, the data plane, most of the threads are oriented to the metadata. That's the new thing related to SFC.
Is that the right slide at this
Yeah, that could be the slide. Yeah, so for each of these planes, we detail the different threats we consider, and then we generalize the threats into recommendations and requirements. And the idea is to make possible to isolate these different planes, as well as to prevent some of the attacks, or attacks should not be only considered as intentional. It can be, for example, when data are leaked, it can be just because it occurs because you have a misconfiguration of some of the boundaries. So this is the requirement are really intended to prevent that to happen. So as I mentioned, management plane is mostly handled in another document, and yeah, SF tenant user plane is something that is considered in this draft currently out of the scope of the deployment of the SFC platform. Next slide. So we have a version 2. We integrated comments received from Martin this time. I think that we did well. This current version addresses all the comments we received so far, but we'd be very pleased to receive some other comments, and we would like to move that draft forward. But
Okay, so the chairs have one higher level question we would like everybody to think about, and we need feedback on the list. Is this document doing what we as the working group need it to do? Is it asking the right questions? Is it providing useful answers? Or is it answering a set of security meaningful questions that aren't the ones we need? So I'd like people to think about, given what Daniel has said, are these the tools we need to spell out the security picture for our SFC work? Or is there something else we need? And if you think there's something else, tell us if you think this is the right way. Maybe it needs some detailed changes. Tell us that so we can move forward, because this draft is being done by the team at the request of the chairs and the ADs, because security is being under addressed, but it has to be addressed in a context that's actually useful for our work. And so I'd like people to think about that contextual question as they review this material and review this draft. And please do review the draft. Okay.
Thank you.
Victor. You have 10 minutes and 11 slides.
Good morning. My name is Boon Wu from Sun University, and today I'm going to present about the controlling of access control of service function to the NS header. So the problem I bring here is there have been many discussions about whether we should trust the service functions or not. But in my opinion, the question is not whether we should trust it, but it is how much we should trust the service function. So normally currently the operators, they deploy and operate the service function. So they have a high trust level on their service function. But even in that environment, the service function is not invulnerable. So they can be manipulated by virus or other kind of malwares. Also, they could be malfunctions and had inappropriate behaviors. In other environments, including the third-party service function, for example, when the service provider want to outsource their services, or in many cases, the enterprises, they rent another service function from another service provider. In this case, they want to protect their SFC information inside the NSX. Also, there are many security threats from the transportation layer between the service function forwarder and the service function. So, previous slide, please. Okay. So, what if when a service function can manipulate the NSX? For example, when they can change the service path index, they might cause the wrong service path redirect. So when they can change the service index, so we can have the forwarding loop, or they can skip several service functions. And the most sensitive information is inside the metadata. If we leak this information, we don't know that whether what information the operator will put inside the metadata. So it could be a tenant ID, subscriber ID. So the summarize is the NSA information is required to be protected. And the first option may be to encrypt the data, but this option is very costly in terms of the resources, and it may cause a high delay. So in this document, we try to provide an inexpensive mechanism to protect that sensitive information inside the NSH. So in this document, we call the information that is the access control segment. It is the area or field within the NSH that we need to be protected. We need to cover it from the other sources that can extract the data from the information. So we have the service function access control list is the definition of service function permission into the information. And the NSS state, it is the set of information that need to be protected. Next, please. Okay, so we have the access control policy. We define the access control list for each service function that contains the access permission of each service function to the sensitive information. Right now we have the three level of permission. It's a hidden, read only, or write. The hidden, so maybe the service function cannot read that information. Read only means it can read but cannot modify. And write is the service function will have the full permission to the information. Next, please. So our mechanism is right now is very simple. So the principle is we only give the information that inside in the NSA. We only give the service function that the information they need to know, and we censor everything else. And then after the service function process the packet, we will recover it back. Or we in here in this architecture we put the two classifier, the increased subsequent classifier and the increased subsequent classifier. They will be responsible for update the NSA and do the handling the censoring, erasing, and recovering the metadata. Previous one, please. So we have the advantages of this mechanism. So in this, we can obscure the sensitive information. We can also detect the abnormal service function behavior, and service functions are unaware of being controlled by the system. Next. So to make this to happen, we have the problem of flow tracking when we have to track the packet between the previous before and after it processed by the service function, so we can recover the appropriate NSA header, NSA state. We have two solutions here. Very simple. It's first one is reclassification using file tuple, or we put NSA state ID into the metadata itself. Next, please. So we have a prototype we implemented in the yesterday at the IETF hackathon. We use Open Daylight as a control plane, and the service function forwarder and classifier is implemented using Open Switch, and the NSA state will be stored in the Open Switch in the form of flow entry. Next, please. So the consideration for our worker after this, maybe we should define a empty mask for service function. So or the idea is to only give the service function what information they need to access. So each service function will define which one they need to know to the control plane. Also, we can have the dynamic metadata scheme for concealing sensitive information. So we should put maybe the dummy value to the metadata and only give the real value when it comes to the right service function. And okay, next please. So we need to ask you for some discussion about should we maybe we should only control the metadata, or we should control also the service path header, including service path index and service index. And we should we have an addition requirement for access control for metadata type 2, because right now we only define it for type 1. And also the mechanism to NSA to synchronize the NSA state between the classifier in case we have different classifier along the chain. Thank you.
I see a question coming up to the mic. Please do. While they're doing that, I would suggest for your consideration and for other people's consideration in other drafts, it may be helpful for you to think about which aspects of this actually require standardization, because much of what you're doing here is internal behavior in an SFF implementation, and you can implement any way you want. We have lots of flexibility in implementation. So you should think for future versions of this draft about the question of what aspects of this need working group approval, disapproval. We can't stop you from doing a lot of this, even if we think it's a bad idea, and we can't force it to be done if we think it's a good idea. So you need to think about what parts need to be standardized. We have 2 questions, but I'm going to cut the mic after that because we have a speaker who's come in specifically to do the next presentation.
Okay, Kent Leung. Yeah, actually related to your question, Joel. So actually I want to ask is that, you know, you're introducing a new function, logical function here, right, for the filtering. How does this fit in the SFC architecture, the framework, right? You have SFF, you have SF, you have SFC proxy and classifier. Where does it fit in this architecture?
In this architecture, actually that in the NS8 document, they define that the service function can also update the metadata.
Okay, so you just said that the service function can update the metadata.
Yes.
But in your case, what you're trying to do is protect the service function, obviously, right? So the function that seems that you're introducing is something that protects, you know, so that the service function would not see certain, you know, metadata, for example, right?
Actually, we are not trying to protect the service function.
Well, sorry, not protect. I guess you're not exposing metadata to certain service functions.
Yes.
Okay, so okay, I'm only bringing this up because I feel like it's kind of related to some things that we're doing. The idea that this new function could be part of a SFC helper, where to fit inside this whole SFC framework. So that's the reason I kind of brought it up. That maybe we can talk offline about how it fits in within the architecture. Thanks.
Okay.
Hi, David Olson, Sandvine. I think, if I understand correctly, you've assumed that the metadata is constant for a flow because that's how you restore it. Is that true?
Oh.
They have a couple of alternatives in the draft.
Okay.
Some of which assume that, some of which don't.
I guess if that was an assumption, I was wondering if you know, if the working group thought that was a reasonable assumption that metadata is constant for all packets of the flow.
It is not something we have assumed to date.
Okay.
Okay.
Thank you.
Thank you, Victor. Next speaker is Adrian Farrell. Thank you for coming over.
Hi, yeah, I'm Adrian. I come from the T's working group, two rooms along, to talk to you. Do I have a remote?
I am your remote.
You are my remote. I will press you. Thank you. So this is
But it's not attached to this. Don't.
This is
won't do anything.
This is a document we wrote to look at providing a BGP control plane for SFC. Obviously, SFC is here, but protocol extension work goes off where the protocols are. And BESS is specifically chartered to work on that. So clearly this is targeted at BESS, but it's really important to get input and review here. And were we to be proposing any changes to SFC architecture or data plane or anything like that, that would clearly need to be done here. So please be nice to me. Joel and Jim asked me to come along. This is not an old document. In fact, it was posted the day before my birthday, and it hasn't even been to the BESS working group yet. So you're well and truly in the loop.
I believe the best discussion is this afternoon.
It is this afternoon, yes.
So people are welcome to come to the BESS session to look at it from the other angle.
Yeah, all the same angle. So objectives: use BGP to discover SFFs. To discover what service functions are supported, accessible through those SFFs, and to distribute information about SFPs. We wanted particularly to make those two functions separable, so you could run half of it or the other half of it. We wanted to reuse a lot of the methodology that already exists in BGP for VPNs. It's actually a pretty similar function. Clearly support the architecture and the NSH documents as written. be guided by the control plane requirements draft as much as we can, and come up with a solution that is flexible, high function. Sounds a bit marketing, doesn't it? But we didn't want a protocol solution that constrained what you could do. In particular, we didn't want to take a slice of the architecture. And last bullet's quite important. We wanted to support multiple SFC overlay networks on the same underlay. So discovery. What I'm going to try not to do is go into all the BGP details, but just talk in the general terms of what we're trying to achieve. So all of the SFFs would speak BGP. They would probably speak to a route reflector, but that's kind of unimportant. Each SFF then supports access to one or more SFs. I guess that's the whole point. And the SFF issues an advertisement for each SF it supports. So that's what overlay network is this SF in, what is the type of the service function, and a unique identifier. And that allows a controller to see what's out there and understand how to build an SFP. We're not really interested in how the controller goes about doing that. We just want to make sure it has enough information to do it. And the last thing is that the SFF needs to be able to build its forwarding table. It needs to understand where the next SFF is for the next SFI in the path. So we do this by having two lumps that are advertised in BGP. The first lump is the service function instance, and that is really this thing that's the service function forwarder advertises. You can reach, if I take it from the bottom upwards, you can reach a service function of this type. The service function instance is identified in this way, and it belongs to a particular overlay. So you get those three things, and the combination then of the route distinguisher and the service function type gives you the unique identifier of a specific service instance. Yep. And then the other chunk that's advertised, and this is advertised down from the controller and distributed in the network, is the service function path. So the purpose here is to let all the SFFs that are on the path know that they're on the path and know what to do in terms of forwarding. So that when they see an an SPI and an SI, they know what to do with the packet. So each SFP that is advertised, what overlay network is it in? It's the same thing. What is the identifier of the SFP? And that's closely tied then to the SPI that's going to go into the NSH, and then a series of hops, because it wouldn't be a path without hops. Each hop is given the context of what is the type of the service function, what is the which specific SFI to use, and what SI do you expect to see in the NSH for this hop. So that comes in this, I could swear I've just done this slide, but yeah. Okay, these are the BGP constructs that do it. So the SFIR is the advertisement, and then the hop comes in like this: service index, service function type, and the unique identifier. So in the uncomplicated case, the path is advertised just as a series of vanilla hops, each with one type and identifier, and then you're done. No choices, nothing, straightforward, and probably that's mainly how it works. So here's a worked example, which I hope is sort of visible at the back. If not, read the draft. So we have 3 SFFs, and they provide access to service functions, and the coloring on the service functions is consistent with the type of service function. And so, for example, SFF1 will issue 3 advertisements saying, look, here is the identifier of the service function instance, and here is its type. So you see 2 orange ones being advertised and 1 blue one. And then from the bottom upwards, the controller is advertising the service function paths. And if we look at just at the left-hand one, that left-hand one matches the red trail through the network. And it's just advertising, look, here's the identifier of the path and the SPI. And then here are 3 hops, and they're going with SIs that are decrementing. Sorry, that was a red flag, wasn't it? SIs that are decrementing by 1. The SF type, the service function types, orange, green, and red, and the identifiers. And that's basically all that's needed in the network for everybody to know what to do. So there's a whole pile of advanced function that is stuff that you can achieve with the control plane without having to do anything special and clever. And in fact, we would probably have had to go through hoops to preclude some of this. So choice of next hop is just as simple as when you define a hop, you provide a list of SFIs. And that allows you to do load balancing, or it allows you to leverage metadata, or it allows you to take feedback from an SF in metadata telling you what to do with the next hop. And we allow that choice to be completely open. That is to say, pick any SFI of a particular type, or it allows you to have explicit control of behavior. And one of those explicit things we've done is say, we'll have some special indicators in the service function type that says, don't just go on to the next hop, but do something different. Change the SI, change even the SPI. So it's explicit control of branching and jumping. And then, well, how do you get between SFFs? That's an encapsulation thing. BGP tells you how to encapsulate. So it's just a question of including a tunnel encapsulation attribute, and everything just works. And the last thing we did was to provide a mechanism for associating SFPs, SFPs being essentially unidirectional, and the need for bidirectionality springing up, and potentially in the future other needs for associating different paths. The association is just a TLV attached into the advertisement of the path that says, hey, I'm associated with this other path. And that's all. So I have 3 slides where I've tried to capture all the questions that I think I've seen on mailing lists, and my psychic powers suggest that you might want to throw fruit at me about. So first one, I think we've covered, is this work for BESS or SFC? And the answer is yes. Is the terminology aligned? Well, our intention, of course, is to be perfectly aligned on terminology, but it's early version of an individual draft, and we are human. So Joel, immediately we posted the first version, Joel pointed out some terminology issues that we went and fixed fairly immediately. So I think the current version is better. There are still some issues about how we describe classification, reclassification, and so on. And that's just getting the language right. That's not us trying to change the architecture. It's just that we're idiots. Whose job is it to decrement ESI? This has obviously caused quite a lot of noise, and I have my own personal views on this, but those views are not relevant to this document. Okay, this document simply does not care whose job it is to decrement the SI. It's a control plane document. So getting that sorted out is a question for this working group to solve. The control plane supports anything, in particular, but not limited to this. We'd be happy if the SF decremented by 1 or whatever. We'd be happy if the classifier reclassifies and decrements, and we're happy if the classifier is co-resident or a separate lump. It's not actually material to the way the control plane works. Yeah, so when can reclassification happen? Again, I believe that's out of scope for this control plane work. It's a really interesting question, and I could probably have lots of fun debating it, but I don't think it comes into this work. Again, it's something this working group has to decide. We're really, from a protocol point of view, we're happy that reclassification is co-resident or in between, just as described in the architecture, and the control plane supports any of that. Does decrement SI mean decrement by 1 or not? Again, I can have lots of fun talking about this, but again, it's not relevant to this control plane document, okay? I think the debate arose because of the control plane document, but actually that was because of the way we were running worked examples, and that made everybody go, oh, what have you done? So we support whatever SFC working group decides to do. Decrement by 1 is supported. Classifier modifying the SI is supported. And if anybody else happens to get in there and make other changes to the SI, it's just going to work as far as the control plane is concerned. Looping, jumping, branching, spiraling, squiggling, twirling, pirouetting. Yeah, the control plane will support them. Again, whatever you put in your architecture, the intention is that the control plane is going to make that possible. There is some danger of infinite loops, and I sense that one of the reasons to be cautious about looping, deliberately looping, deliberately increasing the value of the SI, is that you may get stuck forever. But reclassification, in all the different meanings of reclassification, introduces that danger of infinite looping. So my belief is it's out of scope for the control plane, but this working group needs to think again about looping, loop detection, and the fact that waiting for the SI to get down to 0 is not a guarantee of loop detection. It catches some cases, but doesn't catch all cases. As I said earlier, what this control plane work does is allow specific control of, I guess, reclassification. It allows specific changes that are already programmed into the SFP of changes to the SI and the SPI. And I think that allows the controller to take charge in very much the way that a traffic engineering controller would take charge in a TE network. If it's okay, Lucy, I'll just do the next slide, yeah. So the last slide on points of contention, reclassification, yes, it's really important, and the classifier is defined by you guys, and what is a classifier is out of scope for the control plane work. What we want to do, though, is allow this explicit choice coming from the controller. So it allows a simple next hop choice that you might have for load balancing, okay? When you arrive at an SFF, your next hop is either this one or that one, sorted out. Or it might have some very specific control. Question, does this concept of allowing choice in the SFP work for OAM down or through the SFC network. So I think it does, but you have to be really careful in understanding what OAM is and how it works. In-band OAM, which is how I think OAM should work to actually really diagnose what's happening in the network, in-band OAM will follow the same path as the traffic. If it doesn't, it's not really doing its job. So if you're making choices in the network, the OAM will be subject to exactly the same choices and will go exactly the same way. Out-of-band OAM really, in order to function correctly, is going to have to report back on what choices were available at each point, but it can't really tell you which way the data is going. There is some OAM discussion in the architecture and the NSH document, and we're trying to be consistent with that. I have a question. I suspect you may have discussed this when I wasn't in the room. What's the plan for the SFC OAM framework?
We're looking for a new co-author and trying to move that work forward.
Okay.
Because I used to be the co-author and I'm not going to be. So Carlos is keeping it. Greg has offered, but we're going to see if there are other people. We're going to be moving that work forward, and your inputs on it are very much appreciated.
Great. And so we'll treat that as if it's a live document, even though it's expired, and we'll try to align with it. And the last one, I got asked on the list as well. How does this work relate to the control plane requirements document? So there are some pieces that I pulled out of that. Forwarding requirements are there, and we're certainly compatible with those. We need still to make a deeper analysis of that draft to work out how to point at relevant sections. And yeah, we just haven't done that yet. I do spot two relevant bullets, and those are the ones that say that the control plane is responsible to build and monitor service-aware topology, and for example, by means of dynamic SF discovery. Well, that's one of the things we do, and the other one is provision the SFP forwarding policy tables through the network, and that's the other thing we do. So I think there is some considerable alignment, but we need to do the job of pointing at the right sections.
One thing that I think will help, I think you are well aligned to a large degree, and there was an earlier discussion on we need to clarify that document, it needs improvement. It will help, assuming we stay with the current structure, and that's up to the working group, if you could call out in some paragraph somewhere in the introduction or similar what parts of the control requirements you're addressing, because that control document covers a broad range of things, many of which it is perfectly reasonable for you to say, that's not what we're doing.
Right. Okay. Yeah, we should be able to do that.
Yeah, that shouldn't be a challenge for you. Anyway, we have two questions at the mics, and we need to finish up.
Sorry, Kent Liang. Actually, can you go back to slide 9? I have a quick question that kind of caught my attention there. Yeah, so here, actually, when you say the SFP, you actually indicate it's a service function type, right? So my question is that how do you deal with stateful service functions?
I think that there's an interesting thing that comes both in bidirectional and in choice. That is, if a service function is stateful, you must, ROC 2119, always go through the same instance. Yep. Unless there happens to be some magic glue that moves state around between instances, which I don't want to go there. And yeah, so in my view, the controller who builds the path has a pretty good idea of what functions are going on that path. If a controller is building a path that goes through a stateful service function, it really needs to not offer a choice.
Yep.
Well, let me clarify earlier discussions in the working group, to save another person coming up to the mic, it is also okay if the balancing, if the choice mechanism in the SFF is flow stable.
Yeah.
And that was an alternative we called out in the architecture. But one or the other. Somehow you got to get back to the same place.
Right, right.
Okay, yeah, I think it is related to a discussion on emailing list, right, about the load balancing between the different. So I think there are different options besides the SFF doing load balancing, right? So, but I think it's, I agree. I got your note though. Okay, thanks.
Okay, cool. And we should probably clarify stateful.
Right. Robert, then Lucy, and then
Okay, Robert Rashuk. So assume I have the SFI across a number of SFFs for various reasons. And is the reachability or presence of the SFI enough to select one versus the other? What I'm getting to is BGP the best way to actually propagate utilization or memory information, which is live information from each SFI instance, so I can wisely pick it?
So can I just see if I can rephrase your question to make sure I got it? When you make some choice, like a load balancing choice, you have to make that choice based on knowledge of what the load is. And you're saying, is BGP a good way of collecting that knowledge?
All right, yeah.
No, I don't think so.
And this draft doesn't require that, so.
Right.
But do we need to have multiple control plane discoveries then?
So how do you discover load? I think load is pretty much more of a real-time thing. It's much more dynamic. It's probably even more dynamic than link load in a network. And I would be intrigued to know if anybody's got any ways of measuring those metrics and propagating those metrics, because I haven't seen them at the moment.
Okay, and last question.
Lucy Yang from Huawei. Two questions. One is regarding your comment about the looping. I think currently this SFC architecture and the NSH protocol mandate the certain SF forward implementation, which is whenever the service function forwarder receive a NSH package from another service function forward, must be not to forward that the package directly to another the service function forward. That's something, this requirement that the service function forward has to be implemented to avoid the looping. I think that's the first comment. It's just you receive NSF package from the another service function forwarder, you must be not forward another directly.
I understand that conceptually, and I have trouble aligning it with the discussion that says that an SFF basically doesn't know where it's received a packet from. It's just got a packet with an SI and an SPI, and it looks that up and forwards it. Now, what you're saying is, but it has to know.
Yeah, because you have that topology somehow. Yeah. So yeah, I think this is my first comment. Second comment, in this protocol, you introduce this service function type. Well, that service function type you are going to discover when you the forward function advertise their service function forwarder, advertise what their associated service function or their control plane tell this service function you are type 1, you are type 2. What's so clear?
Just like I don't care how a service function knows its IP address, I don't care how a service function knows its type. It knows it, and then it's going to be talking to its SFF, because clearly if the SF and the SFF are not talking to each other, we're dead. So the SFF knows I have a service function instance I support. This is its type.
Okay, so service.
I'm possibly thinking that a service function may want to be of multiple types, but
yeah, I think that, yeah, architecture not the, yeah, so
yeah,
for sure, that's
right. But you know, from a protocol point of view, that's really easy to achieve. It's whether there's an architectural case for it.
Yeah, the things I want to clarify is the discover protocol. We're going to advertise the service function forwarder. I have a service function 1 with this type.
Yeah.
Okay. Then the control plane with forwarding the route also going to say that for this service function path, you need to use this type and this both need use.
Right.
Okay, I think
But just to be clear, the data plane doesn't change.
I understand. Yeah, listen.
Okay. Eric, you're next. And which presentation do you want first? The use case one. That's what I thought you had said. So.
Hi, Eric Wang from Cisco, and we part of the security BU. We have heard a couple of topics today about security. Just to clarify, and this is about security service functions participating in the service functioning. And they still require the whole SFC security architecture, which is a very good topic we have heard. I have two related drafts and try to cover it in 10 minutes. I'll try to actually get it shorter. Next, please. Updates from the last presentation, and we have some new cases incorporated some review comments. But most importantly, we have quite a new drafts coming to the work group from folks and working on that, and that actually will cover, see how the use cases are covered so far. Next, please. Just a quick recap what we mean by the security use cases. So we are talking about things like firewall, IPS, and we already talk about MPI, AVC, proxy. What is common to those service functions? The biggest one is stateful. Just discuss that attribute. That means you would require the traffic from the same session or same connection always go to the same service function instance. And you need a service function to be able to identify that session. And the service function may not have all the information to identify it. Normally you use the network header, but coming to the next big top category is application processing. The service function may be doing like threat analytics, and it may be handling only HTTP traffic. So how do they associate the traffic without any network context? And you may not even look in the network context. And they may also doing reclassification, and reclassification can only be done once. And that, for example, a typical case I would say is like SSL, TLS header is only you can only identify TLS by using a handshake. After that, that information is gone. So how to make sure the same TLS connection goes to the same service function instance? So those are the problems we need to address when those stateful and application-oriented service function are part of the chain. And some other behaviors like offloads, and they may be a pure consumer of the packet, like a lot of threat analytics. They don't bother forwarding the packet out. How to accommodate them in the service function, and Ken is going to present it later as well. Next, please. So here's the overview of the drafts, and we are very glad to see many of the use cases has been covered by the draft so far, and I'm not going to go through the list, but if we next, please, Joe, and we'll cover one allocation draft that is try to address some of the information we need to carry for the service functions to operate. It covers those use cases, the statefulness, the way to provide some abstract policy policy metadata, and be able to group the sessions so that we can like identify a common source or common protocol type of the connections. And it will be it is an allocation for type 1 and can be part of the type 2 TLV as well. So here's we are proposing the allocation for the network security part. Start with a session ID, which is going to address the the stateful part, and without session ID, the service functions may not be able to associate the traffic to the common session. And we also would like to group the sessions together. A typical example is IPS and our threat analytics. They may want to, for example, to capture all the traffic going to the Facebook, or capture all the social media traffic. In the WebRTC, there will be multiple control and signaling and media connections. Applications need to, service functions need to group those connections and be able to maybe provide the enforcement and also from QoS perspective. So that is a second field will be needed. And the third field is compatible with the DC allocation data center. This essentially provides a common class ID that can be used to apply security policy. Those flags is the same as the flags in the offload draft. And because the security functions in security part could be very heavy, so offloading is an important use case. Be able to cut through when the evaluation is not needed. Tenant ID is address multi-tenancy. And the last part of the is the scores, and these are the security specific classifications. A transaction may start with like a very neutral transaction, and as it goes through multiple security functions, for example, it goes through a URL which has a bad reputation, the score may go down. And if a malware is being observed to be downloaded, the score will further go down. At that time, probably will trigger a security action, like block the connection, even block the complete user. So in that case, we will need a way to carry the classification forward and be able to refine it, accumulate it. That's where the score is coming from. So that's all about this, and we are going to welcome everybody's feedback, especially folks working in the security domain, and keep revising it. Questions?
Okay, let's change the order a little bit, and why don't you try to move quickly through your next presentation as well, as long as you're up, while I find out whether Rory is available for his presentation, which is scheduled next.
Sounds good. It'll be Ken.
Oh, okay.
I'm Kent Leon. I'm going to be going over the receive-only service function and external services. Go ahead. So this was one of the use cases that we brought up earlier. So let's start. Actually, there's two cases. Fundamentally, the receive-only external service function is based on the idea that it is not part of the service function chain. Right? I think that's the key difference between this one and the next one. So the idea, the characteristics of an external service is that it receives the packets from SFF, or it's from the SF, right? It copies the packet, it consumes it, so it doesn't forward it back, right? That's what a receive-only service function or external service would do. Because it's not part of the chain, so it has a lot of flexibility in terms of being able to attach at the beginning of a service path, at the middle of the service path, at the end of the service path, or one or more points in the service path. So, one of the reasons you might do that is to basically troubleshoot user traffic that's going through a service chain, or to troubleshoot this service path itself, right? So, because it provides a dynamic capability, but yet it doesn't impact basically the service path, which is constructed from the service chain itself. So the key function here is that the SFF needs to support packet replication to be able to send a copy of the packet to an external service. All right, next slide, please.
And do try to keep up the pace, please.
Okay, receive-only service function. So again, so in this case, the service function, for example, service function 2 shown here is a receive-only. It's part of the service function chain, right? So, so characteristics of that is that it receives packets from SFF, right? It consumes it, doesn't forward it back. It's part of the service chain, and it's typically limited in terms of where the location is in the service chain, right? It's actually user defined in the SFC policy, right? An example of this would be intrusion detection service, right? It's IDS, where deployments typically use that for availability of the service, right? And they'll basically monitor it and then detect if there's any intrusions afterwards retrospectively, right? So there's a common use case for a service chain. Next. Okay, so we'll go over the packet plane and the control plane very quickly. So in the external service case by SFF, what's shown there basically is kind of a little more detail of what was described. So the idea is that the functionality that's required is on SFF to be able to make a copy of the packet. And based on a control plane telling it basically at which point it needs to send a copy to the external service function, basically. External service, to be clear. And it could be at the beginning, middle, and third. And the other thing is that it does not affect your construction of the service function path, right? The service function path doesn't change as you move this particular tap point along. And one more note about that one was that because it's external service, it doesn't require NSH header, right, to be sent. So the packet is a pure native packet that's sent from SFF. And we skip this one. This is the details of what happens on SFF. Okay, so this is the key part, I think, of what we're trying to do here for the receive-only service function, right? So the problem is really when it's a receive-only service function is that about the SI decrement, right? The whole thing about SFF forwarding is based on decrementing the SI to go to the next hop, right? Because it's a receive-only case, there is no packet to decrement to send back to SFF. But you still need to follow the chain because there might be another service function in the chain, right? So that's kind of the problems we're trying to address. So what we did is that we extended, the proposal is to extend basically the SFC proxy function, the component as part of the SFC architecture. And the kind of additional feature that we have is to be able to make a copy of the packet and send it directly to the service function that's receive only, right? And that includes basically the NSH header with the metadata. So it allows your service function to be able to consume the metadata and make use of it as part of the chain, right? So the key difference here is, so if you follow this kind of traversal of the service functions, SFF's view of the service path remains the same, right? It would go through SF1, go to, when it goes to the SF2, basically the ascended SFC proxy is basically acting on behalf. So SFF would just send it to that ascended SFC proxy. SFC proxy naturally decrements the SI and send it back to SFF. So that part's already there. The extension is basically to be able to send an NSH embedded header toward the SF2. And then it follows through the rest of it. So that's how it will work. And as I mentioned, IDS is a good example of that. And I think I kind of talked about this already. Control plane. So mapping the control plane. So again, part of, I guess, identify where the component sits matters as far as how you kind of have an interface to control it, right, manage it. For example, SFFs by nature, by design, are forwarding entities, right? They're not, they may not be able to support flow states for load balancing or additional filtering, right? That's higher level functionality. And SFF basically looks at this, the path table and makes a forwarding decision, right? So here, basically, in SFF, in this particular external service case, the control plane, we use the C2 interface, tells SFF that, at which point in the service path, you need to make a copy of the native packet and send it to a particular receive-only external service. Next one, please. Okay, so for the control plane for the extended SFC proxy, basically we're going to use the C4, which is the proxy SFC proxy interface, right? Here it's going to tell, because again, this is a functional entity. It can't be co-located in the SFF from implementation perspective, but it's a logical function that we want to make sure is very clear where it sits in the SCC architecture. So here it's going to tell the extended SCC proxy that, hey, you have a receive-only service function above you. You need to make a copy of it with the metadata, and then forward the original packet back to SFF to follow the chain. I think that's it. So Q&A.
Questions? Okay, while Roberta comes up, I will remind folks, if you haven't signed the blue sheets, I believe they're at the back of the room. Please do sign the blue sheet.
Hello, my name is Roberta Maglione. I'm going to present this draft about radius attribute for NSH in behalf of all the co-authors. This draft is targeted at addressing broadband use cases. In particular, the problem we are tackling here is how to map subscriber traffic to a service chaining. Because in several broadband scenarios today, radius is used to store subscriber information. The idea is to define two new radius attributes, one for NSH SPI and the other for NSH SI, basically to map the subscriber traffic to the specific service chain. Here you see a representation, a picture about the use case. And the way this architecture will work is like that. The AAA radius server does the subscriber authentication and authorization for a specific session, could be an IPOE or a PPOE session. And basically during the SSS set, the radius server will send to the NAS the NSH SPI and NSH SI information. And the NAS that is acting as a classifier and service function forwarder will use this information to build the NSH header encapsulation. Basically, we'll copy the SPI and then the SI parameters coming from the radius server into the equivalent field into the NSH header. Here you see the format of the proposed radius attribute, basically TLV for the NSH SPI. We use 32 bits unsigned integer based on the guidelines from the REDX working group. They suggest not to define specific value with a limited scope, just to use the 32 bits and then define the specific range. In this case, we only consider the 24 bits that we need for the SPI. Next slide, the similar format for, next slide, sorry. Similar format is a TLV for NSH-SI, again 32 unsigned integer, and here we limited to just the 8 bits because the SI is 8-bit. And as I mentioned earlier, the behavior of the NAS will be to take the value from this radius attribute and use it to fill the NSH SI field into the NSH encapsulation. This is version 01 of the draft. We submitted version 00 couple of weeks ago. We received some comments on the list, basically related to the data type. So we addressed this comment and we posted version 01. So the new data type is mainly the difference between version 1 and version 0. The authors would like to ask for more feedback from the working group and comment, and also ask to the chairs if this work can belongs to this working group.
Okay, so on the procedural matter, if the working group decides it is interested in working on this, we will then coordinate with the Radius Extensions Working Group to make sure that it's fully coordinated with them. I don't know who will own it, that doesn't matter. But first we have to decide if we're interested in it, then the chairs will take care of doing the coordination with the Radius Extensions guys.
Okay.
Okay, and we are very short of time and we do have one more presenter, but are there any questions for Roberta?
Praveen Mule, Nokia. Have you considered looking at uplink part different than the downlink one in this particular?
We don't have that scenario yet in the radius, but we can discuss that.
Sure.
Thank you.
Thank you.
Thank you.
Okay, Rory tells me he's ready. He is the presenter for this last draft, so go ahead, Rory.
I don't know if the authors are here, but I just received an email from Tal. This draft seemed to define several type 2 TLVs, which I missed in my draft. So he reminded me. So I'm going to add them.
Well, we're going to be defining type 2 TLVs a lot of the time. That's perfectly normal. That's part of the reason one defines a registry, is so that you don't pretend that you can get all of it up front, because any extensible set, you can never get all of the values at the beginning. Rory, we are looking forward to hearing from you. Yeah, he's in the Meet Echo, but we're not hearing anything. And the Meet Echo folks tell us they can't hear him either. Give us a moment. They're suggesting he rejoined, so. I'm sorry for the delay. So again, if you haven't signed the blue sheet, please do so. I'll be collecting them on my way out and giving them to the Secretariat. There are multiple reasons why we need all the names, so please sign the blue sheet. Okay, Rory, it looks like you've rejoined. Can you speak and can we hear you?
Can you hear me? Hello?
Yes. Yes, we can hear you. Go ahead.
Okay, thank you. Sorry about that. Okay, folks. So this draft has been around for a while. It was called time stamping, NSH time stamping before then. We've broadened it a bit. It's now KPI stamping. If you look at the picture on the top right there, very simplified. There is an external control plane which is out of scope here, but that's issuing commands essentially to a classifier to stamp NSH packets in a certain way. We've defined two KPI types, being latency or time stamping and QoS. We use MD2 for the header structure, and we have two generic modes of operation. We have a detection mode to discover that there is a problem on the chain, and we have extensive mode, which does more kind of aggressive KPI monitoring with an aim to do some root cause analysis. And this can be done end to end, in that you only look at KPIs at the beginning of the chain and compare them to the end of the chain, or you do them hop by hop, or you do them on a specific VNF or service function. Okay, next slide. So detection mode is here. We tried to squeeze this into MD1, but we couldn't quite fit it. And this is, essentially a low overhead packet. And what we can do here is we can set a threshold on the KPI. So for example, if this is the time or the latency type of KPI, we can say, this service chain should exhibit latency of less than X, X being the threshold. And if it exceeds that threshold, then we consider that a violation, and we record the SI where that threshold was violated and return that back to an external controller for analysis. All of the timestamps that we're using, so here, for example, if this is a latency example, all of the timestamps are PTP based. And so in detection mode, the ingress stamp is performed by the SFC classifier. There are no subsequent stamps. It's just that it's up to every service function, if they so wish, to compare their given KPI with the ingress KPI and to take an action if so desired. So it's low overhead and there's no packet growth on this. Next slide. Then in extended mode, we use a similar principle. But here we can be more aggressive on the chain, and we can do things on every hop if we so wish. Of course, it's a trade-off then in that the header can get quite long, especially in long chains. And But that's just the cost of debugging issues. So every time we go into extended mode, we write a reference time into the header, which is like a time of day that we're analyzing this particular chain. And we write a flow ID into the header also, so that we can analyze the results offline. We have a stamping service index, which we define, and that defines the generic type of operation, whether it's just stamping at the ingress and egress of the chain, the ingress and egress at a given service function, or doing so at every hop along the chain, such that you can debug where a particular problem occurred. Next slide. So this is extended mode then for latency. Obviously, if you're going to measure latency across chains, all of the service functions need to be in sync. The I and E flags are set for ingress and egress, so maybe you only want to look at ingress timestamps or egress timestamps, and that's set by the SFC classifier under instruction from the external controller. The SYN bits indicate the synchronization status of the SF, and if the SF is out of sync, then it will not write a timestamp, and it will indicate why by its SYN status, whether it's in holdover or out of sync, etc. Obviously, in this mode, if we have many hops, the header can get quite large, and we could hit fragmentation problems. We're not addressing that. I think it's easier to make a simple rule such that the classifier knows how long the chain is. He knows if this is going to fragment given a certain operation, and therefore you can make a simple rule that you don't analyze packets of greater than 1200 bytes, for example. PTP is used throughout as a consistent and common timestamp type. Next slide. Exactly the same principle, but here we look at a different KPI type, being QoS. And the idea here is that to check quasi coherency hop by hop on a service chain, such that layers 2 and 3, and as we know, very often we have multiple layer 2 and layer 3s in the same subscriber flow, that those things are configured consistently across the chain. So again, we can do end-to-end, we can do specific service function, or we can do hop by hop. And essentially the service function will walk the ingress and egress QoS stack as this packet traverses. This will be done extremely infrequently. So if we have 8 quas classes in the network, then we might run this once a day on 8 packets, something like that. Okay. So we define a QT type or a quality type here, and the values that we've suggested are on the right. So this caters for whether we have double VLAN tags at ingress or egress, or MPLS tags, etc. The E bit there that you see at the end of the, just back one slide, please. Yeah. So the E bit at the end of the quality value, that essentially demarks the QoS header. So this is saying this is the last QoS value I have at this side of the SF. So it indicates that the following value is either the other side of the SF or the next SF along the path. Next slide. So some pretty basic kind of result examples, and we have coded this and demonstrated it on slightly fancier graphics than this. So here on the left we have the latency KPI, and here you see as a packet traverses the chain, it's pretty consistent, very short transit time through the service function. But as you come to VNF4, then the processing time across the service function has increased dramatically for some reason. So it indicates that there's a problem in VNF4. And so you can use this to debug, for example, if you upgraded software on a given service function, if that service function is transiting traffic, better or worse than the previous software version. It'll also indicate if there's been a big rise in VLink transit latency. So if there's some kind of undesired transport behavior happening. And on the right, then you see a similar type thing whereby Quas is consistent through VNF 1, 2, and 3, but on VNF 4 we're getting a mismatch. So there's been a quas label written at the egress of VNF 4 which doesn't match up with something on the ingress. So maybe a VLAN 802.1p has been written correctly, or an MPLS EXP bit has been written incorrectly, etc. Next slide. So that's pretty much it. Short and sweet. It's kind of a generic method. It's a toolbox, I would say, or the beginnings of a toolbox as to how you could add debug tools and detection tools to NSH service chains without using, vprobes or manual techniques. It's not an OEM protocol, so this operates on real subscriber traffic. And it's performed on a very small subset of traffic. So for latency, for example, you may examine 1 or 2 flows within a given chain for a certain amount of packets or for a certain amount of time. For QoS, even less again. So that's all I have. Thank you.
Thank you, Rory. We have a couple of questions from the microphone, so let's take those.
Lucia from Huawei. I think this is a very useful, the way to use metadata achieve this. And I think your summary covers my question I want to ask. This only used for on-demand purpose of small set traffic. That's.
Yeah. Hi, Greg Mirsky. I just wonder why you stress that this is not OEM, because OEM is not only active OEM where you inject special test packets, but OEM includes passive and what can be characterized in hybrid, which is something in between of passive and active as defined by RFC 7799. So I would encourage to look at the documents that we discussed in Berlin, and some of these 2 documents will be discussed later this week by Overlay OEM.
Fair comment. Okay, thank you.
Okay, thank you, folks. This concludes the SFC working group session. Please bring your discussions to the list. We need folks discussing these various issues on the list. That's where decisions are made. If for any reason you want to talk to me, I'm around all week. I'm more than happy to talk to participants. Please.